Okay, on your first sheet of patty paper, I want you to use a straight edge. Remember never to freehand anything. You're just going to make a good size segment. So segments, remember, have a definite beginning and a definite ending, and we're going to label those points K and R. And remember, points are always capital letters. So we are going to fold the perpendicular bisector for this segment KR. Now, this is actually a much easier fold than the angle bisector. With the angle bisector, you had to fold side to side and make sure that your fold went through the vertex of the angle. With the perpendicular bisector, all you have to do is fold point on top of point. That's literally all you have to do. And so remember to use the see-through property to make sure you're lined up nice and good with those 2 points, and then you can make the crease. So we really just want one crease. Once you have that crease, remember you can use the straight edge of your compass to make that a little bit easier to see just by copying over that fold line. Now, since this is a perpendicular bisector, I'm going to make a couple of notations. I'm going to, first of all, label this point of intersection. I'm going to label that point M, capital M. I'm going to put a right angle symbol here because remember it's a perpendicular bisector, and do my tick marks on segments KM and MR. So that just shows that this doesn't matter if you put arrows at the end or not. It can be a line, array, or a segment. This is the segment being bisected though. So that's very important that we have endpoints on that. So there's your perpendicular bisector. Now I want you to place some points along that perpendicular bisector. It doesn't matter where. I'm going to do a couple above point M and one below point M. And I'm going to label these as points L, A, and I. Now remember, when we did the angle bisector and we put points on it, we were measuring how far those points were from the sides of the angle. This time we're going to measure how far are these points from the endpoints. And you have a couple of options. Your compass has a ruler along the side, so you could certainly measure this in those millimeters. And so I can see that on mine it looks like from K to L is about 55 millimeters or 5.5 centimeters. And if I measure from R, I guess I would put this on 0, L to R, again, I'm at about, well, I can't keep it there, 55 millimeters or 5.5 centimeters. You could also use a second sheet of patty paper, and you can just trace those points K and L, and there's that distance between them. And then I can move to L and R and see if those match up, and they do. So that tells me that those distances are the same. And so then I could do the same with K and A. This is K, this is A, and then I can move this to see if A and R are the same distance, and they are. So you have a couple of different options. You can use the patty paper method or the ruler on the side of your compass, and usually the millimeter end is easier to measure how far these points are from each endpoint. Now what you should find, and again you can pause and rewind as much as you need to, you should find that L is the same distance from K as it is from R, and A is the same distance from K as it is from R, and I is the same distance from K as it is to R. And remember, it didn't matter where I placed these, it was just the fact that they were all on that angle bisector. Not angle bisector, sorry, perpendicular bisector. So let's look at question 4 of your notes. Fill in the blanks using the choices. If a point is on the line segments, and remember what we folded today, that's a perpendicular bisector. So instead of writing that in that small space, I'm going to use the symbol for perpendicular, which is an upside down T. That means perpendicular. Let me bring this to the center so you can see that. So I'm going to call this a perpendicular bisector using the symbol for perpendicular. Then that point is what from each of the line segments endpoints. So remember, we learned that all of these points on the perpendicular bisector were the same distance. And we have a word for same distance. It is equidistant. Is equidistant. So every point on a line segment's perpendicular bisector is equidistant from the line segment's endpoints. All right, so now we're going to look at a different sheet of patty paper. So if you'll get out your third sheet, and again I'll turn this upside down so you can have a blank surface to look at, you're going to draw a triangle. Now you're not trying to make an equilateral or isosceles or anything like that. We just want a triangle with theoretically 3 different sides lengths. So I'm not going to measure, I'm just going to draw a triangle, and I'm not trying to make any of the side lengths the same length. And I'm going to label this triangle the same way that is done here, which is using points P, N, and K. So I'm going to make this N, P, K. Again, make sure you use capital letters. So what we're going to do is we're going to fold the perpendicular bisector of all 3 sides. So that fold that we did point to point, we're going to do that 3 times. So I'm going to begin by putting points here that'll be a little bit easier to see through the patty paper for P, N, and K. And then I'm going to fold K on top of P. Remember to be as accurate as possible here. That'll really affect your outcome here in just a minute. So really be precise with these folds. I folded P to K. Now I'm going to fold P to N. So again, I'm being as accurate as possible in these folds. And then I need to fold finally K to N. And again, I'm making sure I'm super accurate, placing those points on top of each other. Okay, so you may not be able to see my folds very well. So remember, you can always use a straight edge and go over these lines. It's really hard when it's white paper on white paper for me to see, but I will do my best here. So there's one of my folds. And again, if you need to pause this and get this part done for yourself, feel free. And here is my third fold. All right, so what we're trying to see is if we get the same result as the angle bisectors. And the result that I'm talking about is, did the 3 lines all intersect in one point? And mine did. It was almost on this third side of the triangle. Now, that is not where yours has to be. Yours may be inside the triangle, on the triangle, outside the triangle. The thing that we're looking at is the fact that all 3 perpendicular bisectors did, in fact, intersect at a single point. So if yours did not intersect at a single point, then you need to work on the accuracy of your paper folding, because that's the important thing. Okay, so let's look at your notes, and that is going to be number 5. It says the perpendicular bisectors of 3 what? We did the sides of the triangle, so that's what we were folding the perpendicular bisectors of, the sides of a triangle, intersect at A, and just like the angle bisectors, we're putting single point. Now that single point, just like it had a name for the angle bisectors, has a name for the perpendicular bisectors, and that name is the circumcenter. And so you can see that definition on number 6 here. So it tells us that the circumcenter is the intersection of the 3 perpendicular bisectors of the sides of a triangle, and that the circumcenter of a triangle is the center of a circle, just like the incenter was the center of a circle. This circle passes through the 3 vertices. Remember, the circle for your angle bisectors touched all 3 sides of the triangle. We're not touching the sides here, we're going through the vertices of the triangle. And this circle is called the circumscribed circle. So the circumcenter is the center of the circumscribed circle. The incenter is the center of the inscribed circle. So you can kind of keep those together. That kind of makes sense. Another thing that might help you is that the angle bisectors, angle starts with A, and their center that they all intersect at starts with an I for incenter. So val, val. Perpendicular bisector starts with the P, which is a consonant. It intersects at the circumcenter, which starts with the C, which is also a consonant. So vowel to vowel, consonant to consonant. Angle bisectors intersect at the incenter. Perpendicular bisectors intersect at the circumcenter. So if you'll just match vowel to vowel and consonant to consonant, that might help you keep those straight. So we already answered number 5 in our notes, and now we're going to draw that circumcenter. So the last thing we're going to do with our patty paper is to draw that circumscribed circle. So this is a little bit easier of a drawing than the angle bisector. So remember, the angle bisector, you had to create that perpendicular distance that you used as your radius. We don't have to do that on this one. The radius is simply the distance from this point to any of the vertices. And so I'm going to label this point in the center. I'm just going to call it point R to have something to talk about. So remember, our circle is going to go through all 3 of these points. And I'm probably going to have to keep my paper here because my circle is going to go off my paper, I'm pretty sure. But this is going to be the center of the circle, and the distance from R to N, R to K, and R to P are my radii lengths. And it's always going to be the same length in a circle, so all the radius are congruent. So I'm going to put the center of my compass on R, and I'm going to choose a hole setting on my compass that will go through N or K or R, it doesn't matter which one, and it looks like, if I can keep this straight, that's my closest one. So if you can see there, I have this hole on R and that hole right there on N. So this is going to be the setting I'm going to use for my radius. And so I'm going to do my best to get this to write on my patty paper with the pen. Let's see which one I was using, this one. And keep this as still as possible. And I did kind of move my hand there a little bit, but you can see the gist of that. So it wasn't perfect. I had a little bit of human error in mind. Look, I'm just going to fix that by making those points bigger. That's what you can do too. So you can see the circle goes through all 3 of your vertices. This is your radius setting from point R to K, R to N, R to P. So it doesn't matter which distance you measure to use as your radius. Okay, those are all going to be the same distances. All right, so that concludes our construction. The next video will go over questions 7 through 10, and then your example on number 11.